Hi, this is second application of Monte Carlo simulation, and we want to look at Three Hills Power Company. This company provides power to a large city through a series of almost 200 electric generators. This company is concerned about generator failures because a breakdown costs about $75 per generator per hour. There are four repair people earn $30 per hour and work rotating 8-hour shifts. Management wants to evaluate the service maintenance cost, simulated machine breakdown cost, and total cost so that they can understand the magnitude of the cost caused by this breakdown. There are two important maintenance system components. First is time between successive generator breakdowns, which varies from 30 minutes to 3 hours. The second component is the time it takes to repair the generators, which ranges from 1 to 3 hours in 1 hour blocks. So if you look at the data, they already have historic data regarding the breakdown uh, between the generators. So that breakdown is given here, and also the observation and the probability is already calculated for you. So you can use this number to simulate. Second thing is the repair required hours. Sometimes it requires only 1 hour, sometimes 2 hours, sometimes 3 hours, and they are already given here. And you can use that for simulating the time it takes to fix the generators. So let's follow the 5 steps that we have in going through together. So this one should be Three Hills Company. And step one, establish probability distribution. So we have learned that breakdown data is right here. So I just wrote it down here. Time between breakdowns and the probability. Half times, one time, I mean 30 minutes and 1 hour and 1 hour 30 minutes. That's time between breakdowns. And the probability from the history is derived here. And the total is 100%, so that's good. And we also have this repair time data that's also from the case and time 1 to 3, 1 time, 2 time, or 1 hour, 2 hours, and 3 hours. And probability is 28%, 52%, and 20%. So most of the case, repair takes about 20 hours. Now for second step, build a cumulative probability distribution. So to do this, we have to just add one more column, cumulative probability. And the first class is 0.05. The second class is 0.05 plus the corresponding probability. And if you do that the same for the rest of the cells, then you will get cumulative probability. And the same for repair times data. I did that here. So 28% and 52% times 28% gives you 80%, and then add the 20%, then 100%. The third step is setting random number intervals that we have done so far. So what you do is just multiply this one by 100, right? So then it becomes real number, and copy that down, and that's 100. So I'm gonna just manually do this. For some reason, I cannot copy that down. That's why I'm doing this. Equals this times 100, that times 100, and 1 times 100. Oh, sorry. 1 times 100. And I said, you have to copy this part, right? Copy and go to random number intervals. And then on the second cell, right click and paste special values only. And then you paste those values and start with 0. That's what we have to do. The same goes to random intervals for repair times data. So equals 100 times 0.28. equals zero point 0.8 times 100 and 1 times 100. And again, you have to copy this 28 and 80 and paste it, paste special and values, and then you start from 0. So then you have just created a random number intervals. Fourth step is generate random numbers. To do so, we have to set up the simulation first. So first we have to, the first column is about breakdown number. So how many times does a generator break down, right? And they have 40 generators. So we are just going to go for only 15 breakdowns here. But in real case, you can increase it to say 100 or 1000 if you want, you can do that. But let's just look at 15 breakdown and see what happens. And we want to generate random number. It's easy, right? Rand function times 100 is going to be your random number, and then copy that down. Time between breakdowns, we have to use this breakdown data to find that. So we have done VLOOKUP function many times. So now you must be familiar with that. Lookup 60 from this table, right? And then retrieve a value from the second column. And this is approximate match. So you want to find this. So 85 is above 81. So it's this class, and getting 3 is right. And I just need to fix the reference here. I126, J32, and that's done. And we can copy this down. Then we have corresponding breakdowns. So 3 hours of breakdown, 2.5 hours of breakdown, 1 hour of breakdown, and so forth. And now time of breakdowns. So this is a little bit tricky, so I need to spend time here. So let's say, this case is assuming that the breakdown happens or the generator is working from midnight. And so 3 means 3 o'clock, right? So at 3, it happened. Breakdown happened, and we have to see how long it takes to fix that breakdown. And is it 1 hour repair job or 2 hour repair job or 3 hour repair job? That has to be also calculated. So the question is how to convert the 3 to a time, say 3 o'clock or 4 o'clock. So we are going to use a function called time. And we know this is hours. Time function gives hour, minute, and second. And we want to put this one as an hour. And then sometimes we have, like, let's say 2.5, right? So this 0.5 has to be converted to minutes, right? So that's how do we do this? And we will use this if function, and we want to use right of this column, this cell, and you want to bring up, say, zero point 0.5. Two digit of those cell is equal to, say, zero point 0.5. Then you want to put 30 there, otherwise 0, right? So that's how I worked on. So I worked on it for quite some time and figured this out. So um, right, so 2:30 a.m. It comes right away because 2.5, right? So the function is working. So if we have K38 only, then it's going to be only 2 a.m. However, because it's a 2, but we have a 30 portion and or zero point 0.5 portion, and that is zero point 0.5. So I want to tease it out by using right function, right K38, and then bring out 2 digits of that uh, uh, value from the right, 1, 2, right, zero point 0.5. And if it is zero point 0.5, then you are going to put 3 into minutes, otherwise 0. And the second, we are not dealing with the second, so I'm just putting 0 over there. So now it's 3 because there's no zero point 0.5 there. If there was zero point 0.5, it would have 330 like that. So if you have done that, now it's a time of breakdowns. And now the next one, that's something that we have to look at the other cells too. So I'm going to wait a little bit. The time repair person is free to begin repairing. So if they are working from 8-hour night shift, and 4 people are working on it. Um, uh, so say they are working from midnight, then they are available to work at 3 a.m. So it's no brainer. So we are gonna just say it's 3 a.m. It's the same because it's the first row. But for the second and third row, it could be different because they might be held up by previous job. And now random number for repair time. So how many hours does it take for a repair person or engineer fix things out, right? So we want to create a random function here again and times 100, and we want to just copy that down. And we have repair time required, and that's given from the uh, table that we have created. And we are going to go to repair time data here and we bring up the second column value, and this is true because it's an approximate match. VLOOKUP. So I did not write up there. VLOOKUP, and you want to fix the table location, so add dollar sign, and then you have that. So 34 is in between 20 and 80, so 2 hours is a good one. And then we can copy the formula down, and we have that. So 90, sometime we had 90, and it is above 80, so the time is 3 hours. So I think it's nicely done. I think it's working. Time repair ends. So now time repair ends. So if you start working at 2 a.m., right, when this thing happened, then it takes 2 hours. So then you have to add this. Thankfully, we don't have any um, zero point 0.5 here. Otherwise, you would have been more complex. So what we do is we add this plus time of this, and there's no minutes, no 30 minutes here. So I'm going to just say 0 and 0. Then it's 4:30. So 1:30 a.m. The random number keeps on changing. That's why the number is changing. So 1:30 a.m. it ended. It takes 3 hours. Therefore, it ends at 4:30, right? And number of hours, machine down, right? So how many hours has it been down? Um, so the time repair ends, right? Minus the time of breakdowns, right? So that gives you the hour, right? So here at 3 a.m. and it it broke down at 2 a.m. So it gives you one hour, right? So that's good. And let's go to the second row, breakdown. And here breakdown happens at so time between breakdown, right? So this one has to be after this, 3 hours later, it happened. So, um, in my opinion, it should be time, right? So as we have done, time breakdowns from here plus time of that, right? So 3 hours lapsed, and then we have this problem happening, and that's hour and the minute. We don't have minutes, um, and we have this zero point 0.5 component there. So we have to add if this, and we have to use right function again. If this ends to or equals zero point 0.5, then you add 30 minutes. Otherwise, zero, you don't add anything, and you don't have a second, so you add that there, and then it's going to be done, right? Very good. Okay, it's very good. So I have done that, so it's working. So 2:30, right? 2.5 hours later from the midnight, 2:30, and 3 hours past the 5:30 it happened, and 2 hours past 7:30, 2 hours past, 1 hour past, 1.5 hour past, so and so on, right? Um, it has been done, so that's very good. So I'm very satisfied that we were able to convert this hour into time format, and now time repair person is free to begin repairing. So 2:30 a.m. and this is a little bit tricky, and you have to pay close attention. So 2:30 a.m. you began to work and you were done at 4:30, right? Because it took you 2 hours to get it done. Now, however, from 4:30 you are free to work, right? Uh, and right, so however, another thing that um, you have to think about is you are not right away working, begin to work there, right? Although you could have started working at 4:30 a.m., you are not able to begin to work right away because the breakdown did not happen here, right? So the dilemma here is that you cannot just jump on working on repairing generators because the breakdown did not happen. So here, the time that you are free to begin is actually the relationship between which one is longer, right? So the moment you are done, say you are done repairing at 7:30 and 5:30 a.m. breakdown happened. Although you are done with this one, you cannot you 7:30 you are done, so you cannot go to this job and do it right away. So what you have to do is you have to find which one is bigger. You are free to work on it, although at 4:30, but you have to compare that with your breakdown hours, and you are free to work on that thing when it is broken and you are also ready. So two things have to match, and I think if you use max function, then that problem solves. For example, here at 3 a.m. you are done. However, the breakdown happened at 3:30, so therefore you are able to begin to work at 3:30, right? So that makes sense, right? So um, and I can just scroll this down, copy it down like this. And we have to also time repair ends. So it takes 1 hour. So you simply need to um, do 4, right, plus time and 1 hour and 0 minutes and 0 seconds, right? And then that's going to be your, right. So 5:30 a.m. you are done. 4:30 the breakdown happened at 3 and 4 and 5:30 you are able to work because you are done there. At 6:30 you are done, and 7 o'clock you are supposed to work, and 2 hours it took, 9 a.m. it is done, and 9:30 it happened, so 9:30 a.m. you are able to work, and it takes 2 hours, 11:30, and 11:30 you are done, but the breakdown happened at 10. So 11:30 a.m. you start to work. It took you 1 hour, 12:30, and 12:30 the same. So it goes 12:30, from 12:30 you were able to catch up because the breakdown happened in 2.5 hours. So you're lucky. And 1:30, and you were able to get done. And then 2:30 breakdown happened, and then 4:30 you are done with the work and you are able to work at 4:30. Breakdown happened at 4:30, so that's good. And the schedule kind of coincided and you can work on it. So I see that this simulation is definitely working, and I'm going to use number of hours again, time repair ended minus the breakdown hour, right? So 2 hours, and copy the formula down, and I have that there, right? And 30 minutes sometimes there was a breakdown persisting for 4.5 hours. So that's what we see. And the total breakdown hours. Here I have to add all this time up, and if you just add them, you will have some trouble. So I will show you. 1, 2, 2, if you add them, then it's 53 hours. It's because I already set it up like that. So if you go to right click and format cells, and say, if you do this as a time and um, say hours like that, right? Then it's going to give your result will give you probably 5 hours and 30 minutes like that. So the date format does not understand or add all the hours up. So you have to use a special customized format, and that's this. So you go to format cells and go to custom and write down hour, and uh, semicolon, and meaning minutes, and then colon, and then add this at sign, and you have to also add this bracket before H and close the bracket H, so that Excel can just add them up rather than resetting it every 24 hours. So click on OK, and then you have 53 hours and 30 minutes of total breakdowns you have. And total repair time is just number, so you can use sum function. And 34 hours of repair time you have spent for 15 breakdowns. And the time between breakdowns, if you add them up, so time between breakdowns was about 30 hours and 50 minutes. That's what you can find. Now, if you have this data, then you can calculate um, the service maintenance cost. Service maintenance total repair time was 34, so you can click on that, and then it's $30 per hour. So that's going to be 930. For simulated machine breakdown, we have to use integer, and machine breakdown is this 40 hours times 24 hours. You have to convert that into hours and multiply by $75, and that gives you 2,775 for that. If you have hours there, then you have to add $37.5 as well. And total simulated machine cost is just adding this up. That's at $3,555. That's what we can see in this case if you add them up, right? So this is how you can do simulation. It's quite powerful for you to use two different variables and then see how they are going to be added in your simulation, and then see how things are changing depending on the random events, so that you can see, usually number of hours down was 3 hours or 24, 2.5 hours. Sometimes it happened 4 hours, or 4.5 hours can happen. For example, here 4 hours, because there's mismatch between time breakdown happened and the person is um, done with the repairing, right? So that you can see, and given the cost, you can make a decision to hire more repair person, so that rather than one person working sequentially, two persons, covering these repairs in parallel. That might be one of the options that they should think about. Okay, I hope that this demonstration was helpful for you to run your own simulation later. Thank you.